In this video, I'm going to talk about the power series. Okay, so let us first start with the definition of the power series. So an infinite series of the form, so n equals to 0 through infinity a sub n and then x minus c to the n. If you expand it, you will get, when you n equals to 0, you get a sub 0 plus, when you take n equals to 1, you will get a1 x minus c to the 1, like that, right? And then for n equals to 2, you'll get a2 x minus c to the 2, and so on. Okay, so this is called power series centered at c. Centered at c. We don't write x equals to c. We call this as a power series centered at c. Okay, if you take c equals to 0, what do you get? If you take c equals to 0, then you'll get a sub n x to the n. That's what you get, right? Which is, when expanded, this becomes a0 plus a1 x1 plus a2 x squared plus, and then an xn and so on. Okay, for example, let us look at this example. So this n equals to 0 to infinity, 0 through infinity, x to the n over n factorial. If you expand it, you will get 1 plus x squared over 2 factorial plus x cubed over 3 factorial. It is a power series. Okay, so what is the center of this power series? If you compare this guy with this one, what do you get? So in place of a sub n, you have 1 over n factorial in place of a sub n, and then in place of x minus c to the n, you have just x to the n. So you can take c equals to 0, right? So this is a power series centered at 0. You see that? Similarly, let us look at another example. N equals to 1 through infinity, x minus 1 to the n over n. Okay, if you expand this, you'll get x minus 1. When n equals to 1, you get x minus 1 to the 1 divided by 1 plus x minus 1 to the 2 divided by 2. It is like when n equals to 2, this is what you get. When n equals to 3, this is what you get, and so on. Okay, so this is a power series centered at c equals to 1, because if you compare this with the general power series formula, instead of x minus c to the n, you have x minus 1 to the n. Instead of an, you have 1 over n, right? So an is 1 over n, and then it is centered at c equals to 1. So this is how we find out what is the a sub n, and then what is the value of c, what is the center of the power series. Okay, so the next thing is radius and interval of convergence of a power series. Okay, let us denote the power series by fx. Let fx equals to n equals to 0 through infinity a sub n x minus c to the n be a power series centered at c. Then the domain of a power series, or domain of fx, is all values of x where the power series converges. Okay, so the domain of a power series is basically it is like, it could be a point or interval or the entire real number line, entire real number where the power series converges. Okay, so the domain of a power series is the values of x where the power series converges. Okay, now we know, we have learned the convergence of the power series in the past, so we will use those techniques to find out what is the interval of convergence. Okay, all right, so usually we use geometric series or ratio series, or ratio test, root test, geometric series test. Those are the mainly useful, okay, to find out the radius of the convergence or the domain of the convergence. Okay, now you see that at x equals to c, the power series, the general power series become like that, right? Which is a0, meaning at x equals to c, okay, at x equals to c, the power series has a finite sum. Okay, that means it is converges at x equals to c. So the power series converges at x equals to, meaning that any power series converges at its center for sure. Okay, so any power series converges at its center for sure. So the domain, how did we define the domain of a power series? We say that all values of x where the power series converges is the domain, right? So the domain always contains the center. Okay, the domain of the power series always contains the center, or the center always belongs to the domain of the power series. Okay, so the domain of a power series may be a point on an interval or the entire real number line. Okay, if a power series converges for x minus c, you see that c is the center, x minus c is less than r, then r is called the radius of convergence. okay, that r is called the radius of convergence. And if the power series converges for all real number, then the radius of convergence at that time is infinity. Okay, sometimes a power series converges inside an interval and then diverges outside. That interval is called interval of convergence. Okay, and then when you write that interval as x minus c less than r, that r is called the radius of convergence. We'll see some examples here. Okay, let us look at example number 1. It says find the radius of convergence of this power series. Do you see what kind of power series is? Is this a power series first? So this is a power series because you can write this as, let's say, this can be written as summation n equals to 0 through infinity. You can write this as 3 to the n and then x to the x minus c to the n, where c is 0. So you can write this as like this, right? So this is, it is a power series. It is a power series with what is c? C is 0, center is 0, and then a sub n equals to 3 to the n. Okay, now if you look at this, the format the question is given, do you see that any form of the series? Yes, this is a geometric series, right? So it is a geometric series with r equals to 3x, right? So it converges for absolute value of 3x less than 1, right? If the absolute value of the common radius or the common ratio is less than 1, the geometric series converges. That is, since this 3 is positive, we can write 3 absolute value of x is less than 1. This implies what? Absolute value of x is less than 1/3. So this can be written as x minus 0 is less than 1/3. Why did I write this way? Because to find out the radius of convergence, you should be able to write in that format, x minus c less than r. You see that this is x minus c is what? C is 0, right? Less than 1/3. So what do we got? R, radius of convergence is 1/3. That's what you got. Okay, that is the radius of convergence. Okay, so this question was actually from your book. I think that is question number 10 from your book. Okay guys, so let us do another example. I will present few more examples. Okay, so the next example here is 2n factorial over n factorial. Okay, and then x to the 3n. Okay guys, so let us do this one. So is this a power series? What do you think? Is this a power series? Yes, this is a power series because you can write this as, what can you write? X minus c to the n. Basically n, in place of n there is like 3n, not a problem. This is still n, right? This is still n. So this is a power series. Okay, and where an is what? An is equals to 2n. Okay, factorial divide by n factorial. Okay, and what is c? The center is again 0, right? C is 0. Okay, so what we want to do is we want to find the radius of convergence. If the series converges, and then we want to find the radius of convergence. If the series diverges, then it will definitely converge at x equals to at c equals to 0, right? At c equals to 0 at least. Okay, because all the power series always converge at its center, so the center is 0 here. Okay, so let us see that. So this is a power series. Okay, so to test the convergence of the power series, what we want to do is, let us write down that. Let us use the ratio test. Okay, let us use that. Limit n tends to infinity, a n plus 1. Okay, and then let us not write a n plus 1. You see that? If you remember that the ratio test, it says that whole thing was considered as a n, right? That whole thing. And then what we did, now let us, because we have different an here, we have different notation for an. Let us suppose that u is the un plus 1 over un. Let's do that. Okay, and then limit the absolute value of un plus 1 divided by un. What I'm trying to do here is that whole thing is un, because our an is just 2n factorial over n factorial. I don't want to write an, because there in the ratio test, if you go back and then see that I used symbol an plus 1 and a sub n, right? That is because that an was the whole term of the series. Okay, so what do you get there? You get 2n plus 1 factorial, and then x to the 3n plus 1, okay, divide by n plus 1 factorial, okay, and then times, what is un is that thing, so what you can write that is times n factorial divided by 2n factorial times x to the 3n. Okay, so this is what you get. So if you simplify that, what do you get? You get 2n plus 2 factorial, okay, and then x to the 3n times x to the 3 divided by n plus 1 factorial times, this is n factorial divided by 2n factorial and then x to the 3n. Okay, so we want to cancel the things that are the same, so x to the 3n and then x to the 3n cancel out, okay, and also this n plus 1 factorial is n plus 1 times n factorial, and that n factorial and n factorial cancel out, right? Similarly, you can add 2n plus 2 factorial is how much? 2n plus 2 and then 2n plus 1 and then 2n factorial. That's what you get, right? So you cancel that 2n factorial and 2n factorial. What is left is, oh, by the way, we need to write the limit. Limit is still there, okay? So that is limit n tends to infinity, 2n plus 2, 2n plus 1, and then x cubed. Okay, that's what you get. That is x cubed, and then divide by n plus 1. That's it, n plus 1. Okay, now do you think this limit is because you see that there is n square on the top, there is n on the bottom. If you use the L'Hopital's rule of that, well, you don't need to even lose, because you see that for the limit n tends to infinity, this is like a constant, x cube is like a constant, but you just use the L'Hopital's rule for n, okay, and you will get, so that will be 4n square is the highest degree term, there is n, so if you find out the derivative, you will get 8n divided by 1, so that will be infinity. So diverse, so this is greater than 1, right? Greater than 1 meaning this series basically diverse, okay, but all the power series converge at its center, right? So let me write down that. So the series converge at x equals to 0 only, meaning, so the radius equals to 0, so the radius of convergence is 0 here. You see that, as I mentioned here, if the power series converge in an interval, that r is the radius of convergence. If the power series converges for all real numbers, then infinity is the radius of convergence. If the power series diverges, then it at least converges at x equals to 0 only, right? So at the center only, I would say. So at that time, if the power series converges only at a point, then the radius of the convergence is 0. Okay, guys. So we will see some more examples.